Hey, and welcome back to another Learning Java 2D Game Programming video. So, in our last video, we fixed the render offset a little bit. So we already had some render offset, and you all know why by now. From a position, when we draw an image, it always starts from that position and draws to the right and down. So it's never centered or anything, and we actually wanted it to be by the feet. We want the position to be by the feet. That makes more sense to us. So we let every object decide its own render offset instead of keeping it inside of the camera class. However, I found that apparently some bugs were introduced. So as you can see right now, they can sometimes pass through us. And that is because we need to also offset the collision box. And we do that in the getCollisionBox method, but we didn't do it in the willCollideX and willCollideY methods. So what I decided was, had the collision box size been the same size as the unit size or the sprite size, then we could have used the same offset. But for our moving entity, it is not. And the offset is, of course, depending on the size. So we're gonna need a separate position, that is the collision box offset. So as you can see here, this collision box, which belongs to the selection circle, isn't where it's supposed to be, and that's because the offset isn't added to it either. So we can fix both these problems by adding this collision box offset. So let's do that. Let's go into the game object, and under render offset, let's add another position called a collision box offset. And by default, we're gonna let that be 0 as well. All right, now let's go into our moving entity, and we want our collision box offset to be a new position of collision box size get width. And I know this is starting to bloat, so we probably need to do something about this class pretty soon, but I'm gonna leave it for just a little bit longer. So this is the collision box offset that we want for our moving entities, and if you go down to get collision box, you can see that we were doing that here. The thing that we just did, we're doing that here, and we don't want it to be like this. And I actually want to make it a little nicer. So last time we added an add method to our position, and now let's add a subtract method. That way we can just say that this position that we have, subtract the offset. So collision box offset. Let's just generate this method and fill it in. So just like above, but with subtraction. Get x and y minus equals position get y. All right, so this should be good, right? However, we wanted to fix that thing here as well. So when we're calculating with this motion, let's also subtract the collision box offset and the collision, subtract collision box offset. Okay, now that should have fixed our problem. Let's just see if they now stop the way they should, and it looks like they are. So awesome. Now if you want to fix that this collision box isn't on top of our selection circle, we'll fix that just real quick. It doesn't really matter though, since we're not colliding with it currently, but let's do that. So first of all, just get the local copy of this position, and inside of get position we already do a copy, so we don't have to be afraid that we're doing anything. So let's subtract collision box offset, and let's use this position when making our collision box. However, right now we haven't set this to anything, and since it's the same size as the sprite or the object, we can actually just use the render offset. So right now they are the same. If you change one, you change both. And if we just check that out, you can see that that worked. So now our collision box is on top of our selection circle. Awesome. So, sorry, I'm gonna keep this up. So I'm gonna talk about what we're gonna do today. So today we're gonna actually target our NPCs, and this selection circle is gonna be on the NPC that is currently our target. And we wanna find the NPCs that are in front of us. So if we're looking this way, we want anything that is in front of us here. We never want to target someone who is behind us, right? So we're gonna use some maths, some simple vector maths. So maybe this will be a little bit longer, but I hope it will be worth it. It's gonna be fun. So let's get to it. The first thing I'm going to do is I'm actually going to go into our vector 2D class because I know we're going to need some stuff. All right, so we can get the length, we can normalize, we can multiply by a scalar value. First of all, let's make a helper, the copy of that we have. It's going to be useful for us. So copy of vector 2D vector return new vector 2D of the vector get x and the vector get y. Okay, so the things that we're gonna wanna be able to get a vector which represents the direction between two positions. And so give it a start position and an end position. And it's not too hard to get this direction. So first of all, make a new vector 2D. And for the x, just get the start, get x, and subtract the end, get x, and do the same for the y. So that kind of makes sense. However, to just know the direction, we don't need it to be any sort of length. And actually, if we're gonna use this vector later with another direction or any other type of vector, we want them to have the same lengths. And a way to always know we have the same length, of course, is to make it a unit vector. So the length is 1. So we normalize it and then return the direction. So we always know that if we get a direction, it will be a unit vector. It will be normalized. All right, so the other thing that we're gonna need is the dot product. So this will return a dot product between two vectors. So vector 1 and vector 2. And the way that we get the dot product is we say vector 1 get x times vector 2 get x. And then we add that to vector 1 get y times vector 2 get y. And I'm no expert here, so if you want an in-depth explanation of the dot product, then I suggest checking out YouTube. There are a lot of good people who could explain this to you a lot better. But we're gonna use it to determine whether something is in front of us or behind us, so we don't target people behind us. That's what the dot product will help us determine. All right, and then let's go to our position class. So we now have the subtract, but we like to be able to tell the distance between two positions. All right, so let's make a public double distance 2, and we'll take in a position which is the other position. And first of all, we want the difference between x. So the delta x is this get x minus other get x. And the same with the y. So the delta y. All right. And now we want to return the square root of each of these to the power of 2, I guess, summed. So like that, delta x times delta x plus delta y times delta y. So that will give us the distance between 2 points. And I think that might be it for that. All right, so now we're gonna have, where do we want to start? So if we go into our player, because our player is the one who's gonna be checking all of the targets and everything. Let's see how far we can come with this. So first of all, we're gonna need a target. We are going to want some range, so we can't target something several hundred meters in front of us. And we're gonna want to keep a reference to the selection circle, which belongs to us. All right, and I'm gonna start by, I'm not sure how we're gonna do with the selection circle because we keep a reference here. Currently we don't have the state, so we can't add a new selection circle to our game state. So either we take it in here or we take in the state. And I'm not sure which one is best yet. Let's start by taking in the selection circle here. And I'm gonna set the target range to something. I'm just gonna say, so 1 tile away is what we can get. Yeah, it can be replaced with game sprite size. I'm just not sure yet if 1 is enough. All right, fine. Fine, IntelliJ, you win. Okay, so now we're gonna actually want to bring back the update method because now we're needing it. So public void update state. And first we want to call super updates using the state. Then we want to handle target, passing in the state. All right, so in this target, what do we want to do here, right? We want to first find if there is an NPC within our range. So let's just get an optional NPC. I'm gonna call mine the closest NPC. Find closest NPC. And this also needs the state. Let's make that. Okay. So now we want state, get game objects of class, npc.class, and then let's call stream on that. Now we want to filter it. So here's where we want, okay, so first of all, we only want the ones who are close to us. NPC get position. So the distance between our position and the NPC's position must be less than our range that we set. Okay, and now we also only want to get the ones in front of us. So we're gonna need to use the dot product somehow. And I'm gonna say is facing. And then I'm gonna give it the position of our NPC maybe. So we're gonna need to create that method. And also at the end, we want to use the comparator, which we've already used, comparing double. We only want 1, right? So this is going to get us the ones that are inside of our range and the ones that we are looking at, but we only want 1. We want the one that is absolutely closest to us. That's going to be our target. So we can get that now by saying position distance to NPC get position. So this will of course give us the one with the smallest distance to value. All right, let's create this is facing. I don't want to do that in the player. I'm actually going to do it in the moving entity. I'm just going to remove this. We're not using it. All right, so now we're going to need to find some directions. So first of all, public boolean is facing, and we take in a position. So the direction between our two positions. So first, let's get our position. Sorry, let's use the other position. Let's not call this position because that will be confusing. Other. Okay, so first the other position, and then let's get our own position. So first we have a direction between our positions, but we want to know our own facing direction as well. And right now, we do not. So what we have this motion get vector, and this will give us our moving vector, which is also our facing vector, of course, but as soon as we're not moving, this will be 0, 0. So it's not gonna work for us. So we have something called a direction. It's currently an enum. And maybe we want to do this. Maybe we want to turn this into a class so that it can also keep the facing vector right now. Or we could map these. All of these things are going to take some time. So we might want to do something better than the solution that we're doing now, but we need to, I want to complete this today because it will be fun. So let's just keep a direction vector in here. And as I said, maybe we want to put this inside of the direction. Maybe we want to redo this into a class instead of an enum. Let's not worry about that right now. So the direction vector, let's keep it together with the direction. Let's first make that into an empty vector. All right, and somewhere we handle manage direction. Right, so if we're moving, then we can use this get vector, but this will be the movement vector. Maybe we can say get direction. And the difference is we want it to be normalized, of course. All right, so let's just say direction and say vector to the copy of vector, right? So we don't do anything with our own motion vector. That might have weird consequences since we're applying this to our position later. So first we have a copy. We want to make sure that this copy is normalized, and then let's return that direction. All right, that seems good. So if we're moving, then we can update the direction which we are facing. So I think that will be good. All right, now we can do something about this. So let's find the dot product between these two directions. So the direction between our position and the target's position, and the vector which we are facing in. So let's hope that those are facing each other. So what we do is, let's call this dot product. Let's use the direction between our positions and then our own facing direction. So let's return if this dot product is larger than 0. So here's what I talked about. This dot product, if it is larger than 0, then our target is in front of us. If it's less than 0, our target is behind us. All right, that should be good. Let's go back into our player. All right, we have this. So here we go. We have checked the closest NPC. So either we have something or we don't have something. Let's just check that first. So if we have something, closest NPC is present, then first of all, let's unbox it. So closest NPC get. Then let's say if our current NPC our current target, if that's not the same as the NPC that we just found, then we are switching our target. So that means that selection circle needs this NPC to be its parent, and our target will be this NPC. Right? But then if nothing is present, then I want to say selection circle clear parent, and we don't have that method yet. Also, our target will now be null. So let's make this clear parent, and I'm going to create that inside of the game object. This just says the parent is null. All right, what else do we have to do? So while I was thinking about the parent, let's actually do this with a selection circle. We're not going to instantiate a new circle every time we retarget something and then delete it whenever we're not targeting something. I don't think that's not necessary. So what we're going to do instead is here in the get sprite, we're just going to check if parent isn't null. So if we have a parent, then return our sprite. But if we don't have a parent, return null. So images can of course handle null. All right, I'm just gonna see. We're taking the selection circle. We probably have to go to the game state now and see here. So just to try this before we set the parent to the player, we don't want to do that anymore. Let's create this circle before we create the player, and let's pass this circle into our player object. Let's see what this did. Let's see if we missed something. So as you can see, we are targeting people, and we're not targeting them if they are behind us, but if we turn around, it is working. So this is awesome. Now we can, in the next video, start doing something to our targets based on input. So when we press an action button, we are going to be putting them in a bubble where they will then later soar off to safety, and they will not be able to infect any more people. So this was a bit of a longer video. We did some maths, and I recommend you check out. There are a lot of great videos if you want to learn more about dot products and things like that. But I think this will be it for me today, and it's cool that we have this functionality now. So thank you for watching, and I'll see you soon. Hej då!